Consider the region capital R bounded by the line y equals 32 minus 7x and the parabola y equals 20 minus x squared. To find the volume of the solid when R is revolved around the y-axis, evaluate the integral, and we're supposed to set up that integral. How'd they get that? Well, this one's pretty tricky. First off, I went to the 3D Desmos graphing program and I put in the functions. Now remember, when you do that, you have to see this is a function of y and a function of y. So you gotta get x alone in both those equations. So let me jump to this. Here's what I really did. I actually went to the 2D Desmos grapher and I just couldn't see it. It's they're so close. So what I did is I just went ahead and solved it by hand. What do I mean by hand? Well, let's find out where they intersect first off. So let's grab this equation and this equation. Where do they intersect? When 32 minus 7x equals 20 minus x squared, right? That's how we find out where two curves intersect. We just set them equal to each other. Okay, so now I'm going to grab this x squared. What do we always do with an x squared equation? We get a zero. We get the x squared over here to the other side. It'll be positive x squared plus 32 minus 7x. And then jump that 20 over, also be a minus 20 equals 0. And then gather like terms. Minus 7x. 32 minus 20 is 12. Okay. And then we can factor that. X times x. What multiplies to be 12 and somehow can add to be negative 7? 4 and 3, both negative, huh? Because negative 4 times negative 3 multiplies to be plus 12, and negative 4 and negative 3 add to be negative 7, don't they? So then you know the drill. It's just going to be opposite, opposite. So x equals positive 4 or positive 3. So those are the two x values. Let me just write x here, where they intersect. I just found that by hand. Because again, if you graph on the Desmos, even the 2D grapher, it's hard to see anything. They're so close. So then I just solved it by hand. Okay, now let's find the y values that go with that. How do we do that? You can plug into either one. I'll just grab this one. As they intersect there, they're going to have the same y values at those points. So at x equals 4 anyway. 20 minus 4 squared. That's 4 squared 16. So that's going to be 4. So x is 4, 4. So that's the point 4, 4. And the other one, again, I'll use 20 minus x squared. Plug in 3. Oops, it's a funny 3. So y is 11. So that's the point 3, 11. So I got their two intersection points, intersected 4, 4 and 3, 11. That allowed me to make my own graph. Again, the Desmos 2D grapher or the 3D, it's hard to see anything. You can try it, but you'll see what I mean. So, but what I know is they intersected 3, 11 and 4, 4, right? Just found those points, 4, 4, 3, 11, because I set them equal to each other and solved. Factored. Okay, so, and I know this one's a straight line. Whoops. So this one's a straight line. Y equals 32 minus 7. It's a straight line going down. It's got a negative slope. So it's just right there connecting. Just let it go beyond those 2 points. It's my little graph. Parabola. Well, that's like a U shape going down, right? It's a negative x squared. It's a U shape going down. And so I know it must go out like this. How else are they going to hit and intersect in the same 2 points? It couldn't be over here because that's no longer U shape going down. It's got to be concave down and it's got to hit those 2 points. So I just now really it's super close in reality. That's why you can't even see it on the Desmos 2D grapher. But I just exaggerated it out just so I could see what's happening. Okay, so this is the region R that we're talking about. Um, yeah, this is the region. And we're going to rotate this region R about the Y axis. So this here is the Y axis, right? That's what they said. Revolved around the y-axis. The region R is revolved around the y-axis. So when we revolve, I can tell what's going to happen. This kind of shape's going to come over here, isn't it? And 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 so now we got a bunch of washers. We're gonna fill it up with a bunch of washers. It's gonna be three-dimensional shape. Now, when I did the 3D version, I could see the washers. So I just clicked on the I just clicked on the disk washer button. But I had to put these in as X. Remember, whenever you have f of y, that's X equals. And what does X equal? Well, we know. If you yeah, by the way, I saw it. Let me show you. I took each of these equations and I solved for X. Got X alone, right? I just jumped the X squared over, became positive, jumped the Y over, became negative, square root both sides. There's X alone. The other one, I just jumped the 32 over, divided by -7. There's X alone. So I got X alone in both cases. Now you can put that in and that in into the 3D grapher, which I did. There they are, into the 3D grapher for the F and the G. And then I had the thing go from 4 to 11 because I know we were going from down here at 4. Bottom is y equals 4, and the top was 11 is the top. So I can tell from the graph we're going from 4 to 11 because I found those two intersection points. So I had the A and the B be 4 and 11. All right, and when I did, and then I hit the disk washer button, there we go. I got the three-dimensional shape. Now it's very thin. It's hard to see inner washer, outer washer, but we can see it right here, inner radius, outer radius, because I exaggerated the thickness. Okay, so you know how to find the volume of a washers. Volume of each washer is equal to pi capital R squared, like outer radius squared, minus pi inner radius squared times thickness, which in this case, thickness is going to be dy. See that right there? That's the thickness. That's how thick it is. Okay, what's the outer radius? So here we go. We're coming on down. We need pi. We need the outer radius. Well, you can see it. The outer radius goes from the middle to the out. And what is that? Well, that's the x value, isn't it? Right? Whenever you go from the axis out to any graph, that's called the x value. That's how we graph, right? Think about going from the You go over x, up y to get to that point. I'd go over x, up y. So this is the x value to this. Well, I already found that. Here's the x value to that. Right? For that parabola, I solved for x. Square root of 20 minus y. So that's going to be, oh, okay. So this is square root 20 minus y squared. There's that. Minus pi. And now the little radius. What's the little radius? Little radius is right there. Now that's again going to be the x value, again, because it's over. It's the x value. But it's the x value to that line. In fact, let me just change the color for clarity. It's the x value, this x value, right? Because it's, again, whenever you go, if I was to find this point, I'd go over x, up y, right? And so the over is x. It's the x value to this line, which is that right there. So I go, oh, okay. That's it. Minus y over 7 is 32 over 7, if you can read my thing there. And then squared for that. Okay. And then we're going to put the thickness, which is dy, because we're going up the y-axis. Thickness is dy. All right, it's integral time. We're going to take the integral from y equals to y equals, from the bottom to the top, from y equals 4 to the top 11. So there is the integral to find the volume of that strange shape, and that's the answer they got from 4 to 11. They got the squaring canceled the rooting here. You can do it either way, minus. There's the other function squared. They just let the square cancel the root. That's fine. And they put the pi in the front. That is nicer. And so there we go. That's a challenge when you really have to graph it by hand because they're so close in here on the 2D Desmos grapher. You can't really see it, but we can solve it. We know. We know how to find where two equations. So it all started by finding where they intersect, set them equal. I found 4 and 3, plug in to find the y value. So 4, 4, and 3, 11. Once I had 4, 4, and 3, 11, I knew one of them was a line, the other was a parabola going down. And then I could think about rotating it and think about washers, inner radius, outer radius, and we could get the volume from there. I had to solve for x in both these. And you could use a 3D grapher if you want. Probably better not to use anything on that one. And so there we go.